very thoroughly monitored. One more division, the nanotech metal divisions. Incidentally, Holtec International started with high-level engineering analysis part of the nuclear solution process, but we could quickly establish ourselves as a very detailed and integrated solution provider, and one of our latest contributions to this footprint enhancement process has been the development of metamic and metamic HT, which are materials that ensure reactivity control in a plant's fuel pool. We have established our own manufacturing facilities, and we have metamic is a metal matrix composite of aluminum and boron carbide made by a unique powder metallurgy process developed in the 1990s. And to this end, I would like to mention that we have developed a nanotechnology research center at the University of Pennsylvania in collaboration with the University of Pennsylvania to further research in these areas, which we believe is very significant in terms of controlling criticality, safety in the nuclear power plants. Our activities do extend beyond the nuclear power. We are also suppliers of various kinds of power plant components all over the world, including some modern technologies like air-cooled condensers, etc. We are working in India towards development of these items, manufacturing facilities on those lines, and we would love to be, partnering with local partners over here. Our manufacturing division was acquired in 2004. We do manufacture to all ASME code stands actively used in the industry, nuclear and non-nuclear. Our workspace, our plant is one of the largest suppliers of capital equipments in the nuclear industry in the whole world. We are a very, very large and very significant exporter as well. The Orville plant is our fabrication plant and focuses on extrusion and fabrication of aluminum products, produces the metamic and metamic HT elements that I just mentioned, and we're using this facility very effectively to supply to our worldwide customer base. This is a slight departure, and I'm going to run through this very, very quickly because I do want to earn my extra dessert. We are one of the participants in the SMR paradigm. We did listen to some SMR presentations this morning, and we want to say that Holtec has utilized its fundamental corporate principles of safety and security and our particular knowledge and commitment to the needs of the emerging nations to develop our SMR called HISMAR. HISMAR is Holtec Inherently Safe Small Modular Underground Reactor. HISMAR at a glance. I'm not going to try to read all these parameters to you. What I do want to say is, these parameters are very, very key in creating and maintaining an ideal small modular reactor that is safe and at the same time very economic. I'm going to run through these pictures. I had plans to go into some details, but in the interest of time, and I thought I would just cruise through those and get into the point of it really. What's the safety and security aspects associated with it, and what are the key features. This is a containment building overview. This is the power loop, the reactor vessel at a glance, the fuel cartridge design features. The presentation will be available on the website, I was told, so I'm sure you will have access to this and take a look, and we're always available to discuss and respond to your questions. But what I want to really focus on are the design features that ensure utmost safety. This is really, truly relevant in the context of today's discussion. Small modular reactors are part of solutions of an emerging countries or emerging geographical areas energy solution. This has been accepted, and the business industry is working on several projects in the US and elsewhere in the world. For HISMAR, our focus has been on minimizing the number of active components, the underground location of the safety systems, no reliance on off-site power and on-site power for safe shutdown of the reactor, a very robust core design, an integrated reactor and steam generator, elimination of pipes, and finally wet and dry storage of spent fuel. This is our specialty area, so we made sure all elements of that solution is available here. Minimum number of active components is the key item here. Circulation of the reactor coolant occurs without pumps. The process is natural. All the key safety systems that are engineered are fail-safe, passive, high-pressure core injection system, boron injection, automatic depressurization, passive core cooling systems, and passive containment cooling system. We are available at our booth to discuss these items should anyone be interested. Underground location of the safety system is very key. This provides maximum protection from external natural events, maximum protection from malevolent human intervention, so safety, security, and minimum occupational and off-site dose consequences. That is also very, very key. No reliance on off-site power and on-site power for safe shutdown of the reactors. A very robust core design. I'm not going to get into the technical details here. I wish to say that the reactor system is designed to withstand the strongest design-based earthquake postulated for any existing US nuclear plant. And that will probably generally be applicable to plants worldwide. This is the core components. The integrated reactor and the steam generator system, no interconnecting piping, is a very, very key feature that ensures inherent safety. The wet and dry storage of spent fuel, I have spent enough time earlier on this. We have implemented Holtec patented technologies licensed by the NRC already. That's becoming part of our spent fuel storage system and this HISMAR implementation. HISMAR incidentally is in the process of detailed engineering and design. We have teamed up with Shaw, used to be Stone Webster, in doing that. We have made some significant progresses, and we are exploring opportunities to work with the ARC and the Department of Atomic Energy in India to follow a parallel path. We'll see what happens in the next few months or so. My concluding remarks: the HISMAR design, protected by an array of patents, more than 30, takes full advantage of advances in technology, including analytical techniques, materials, and fabrication methods. Our goal has been to approach it from an integrated viewpoint. All capital equipment will be shop manufactured and site assembled to maximize quality and maintain a controlled schedule. Plant build life cycle is projected to be 2 years. All vital equipment and systems are protected by missile shield, providing an additional defense against terror. So 9/11, Fukushima, Holtec International has been trying its best to incorporate an integrated approach. Ladies and gentlemen, that'll be my last concluding remark, and with that, I believe I've earned my extra piece of the. Thank you so much. See you soon.